In this video, I'm going to review you on how to do linear regression, which is to take a set of data like you see in this question over here and put it into your calculator in a spreadsheet or table and actually get the calculator to tell you the line that models that data. In this example here, you can see on number 22, it says it is a linear function. Whenever you're going through the STAR test, make sure you look and see. It'll tell you linear, quadratic, exponential. Those are the types of functions and relations that you have. And most of the questions will tell you linear, quadratic, or exponential, so you know what you're dealing with. So this one is linear, so I know it's linear from the get-go. So what I'm going to do first, before I do the correlation coefficient, is I'm going to run my linear regression, which means I'm going to take all this data and figure out what linear equation. And remember, linear equations are of the form y equals mx plus b, where m is your slope and b is your y-intercept. We are going to actually figure out what y equals mx plus b equation matches this data that's in this chart here. So you're going to go to your calculator and we're going to click on spreadsheet. If you look at the home page, I'll go back to the home page for you. You can click directly on the spreadsheet. You can also do new and choose a list or a spreadsheet. So there's multiple ways you can get there. So we're going to enter a spreadsheet. Now what we have to do on our spreadsheet first, or our table, is we have to tell our table what we're entering. We can't just enter a bunch of random numbers. So I'm going to click at the top here. You see where it says A? I'm going to click, and I'm going to call that my X coordinate. And I'm going to click in B, and I'm going to call that my Y coordinate. So now the calculator knows where my X's and Y's are, X and Y values. If you look here, it tells you in the table, this is X and this is Y. Normally the table is written with the X values on the left and the Y values on the right, because when we graph with X comma Y, X being your left and right, and Y being your up and down. And once again, just to kind of remind you and get the vocabulary in your head, X is your input for a function, or your domain, and Y is the output of your function, or the range. So we're going to put all of our inputs, our domain, our X values in this column here. So 153, 629, and again, I'm using these values right here. 471, 914, 307, 1045, 510, 1106. So I've got all my values entered. And the nice thing about this is we don't have to put these in numerical order. We just have to make sure the X's and Y's match up. So over here in the table, do you see how you go from 1045 down to 510? It jumps all over the place. You don't have to put those in numerical order. You just enter them exactly as they appear. So we've got 14. Now I'm doing this column. These are my Y values, 38, 30, 53, 21, 60, 32, 63. So now I've entered all of my X's and Y's. So what I can do now is I can actually get the calculator to tell me, because I know this is linear, what equation models this data. You're going to hit Control, Document, and then you're going to add a Data and Statistics page. This is always what you do for regressions, for finding equations. Then you're going to get this mess, and we have to tell the calculator how we want our graph to look. Well, we're going to use our standard Cartesian XY plane. So our horizontal axis, left and Y, will be my X values. You see how it arranges them. My vertical axis is my Y values, or my Y values. And you can see there, it's linear. You can see the straight line being formed. So now that we've got this, we're going to go to Menu, and we're going to analyze this graph. And we're looking for an equation. Whenever you're looking for an equation, you go to regression. Regression is a complicated, complex vocabulary word for finding an equation, finding what we call a line or a function of best fit. So I want mx plus b. So I click mx plus b, and there is my linear equation. Y equals 0.051935 x plus 5.53927. So that is a y equals mx plus b situation. This particular question over here says, based on the table, what is the best prediction of the number of clicks on the advertisement if 1,500 people visit the website? Okay. So based on this table, you can kind of look and see what the patterns look like. And they're wanting you to predict what happens if 1,500 people visit the website. Well, let's look at the equation you just figured. And we've got our equation. So I'm going to take this to make that prediction, and I'm actually going to graph it. So I'm going to take this equation that I have right here, and I'm going to write it down over here. So I've got y equals 0.051935x plus 5.539, and I'll just write the 27 down here because I ran out of room. So I'm going to come back over here, and I'm going to go to graph. And I've already got a graph on my scratch pad. This is some stuff that I used earlier. So I'm going to click on scratch pad, go down, arrow down, and you clear it. So I'm going to do a new graph, and I'm going to graph 0.051935x plus 5.53927. Now remember, that's my equation that I got. I'm going to hit enter. So X's are number of visits to the website, and Y's are number of clicks or advertisement. And we want to know which is the best prediction of the number of clicks on the ad if 1,500 people visit. So I want to know if X is 1,500, what's Y going to be? So I'm going to come over here, and I'm going to hit menu, and I'm going to do table. Now remember, these are my X values here, okay? These are my X values. I want to look for when X is 1,500. Now that's a lot, right? So you can actually come down here, oops, and you scroll down until you get to 1,500. I'm sure there's a faster way to do it, and I haven't figured it out yet. You can go to 1,500. There we go. This might take a little bit of time. So let's go to 1,500. There it was. 1,500. If there are 1,500, the projection is about 83. So 1,500 people visit, the projection is 83 clicks. So your answer is 83. Once again, what I did was I went back. I went to my documents. Oops. I went to documents. Let me go to current. Okay, current. If you go there, it goes to current. That tells you where you are. I put everything in a table. I did a stats. I did control doc, added a doc. Made this the x-axis, made that the y-axis. Did my regression. I analyzed the graph, did a regression for linear regression, got my equation. I took that equation, and I went to graph it. And when I went to graph it, I checked the table, and there's my answer. I'm looking for 1,500. There you go. So we're going to look at a correlation coefficient, which is R. And R tells you how closely things are correlated. Correlation means a relation. How are they related? Are they related to each other? Do they affect each other? And there's different types of correlations that we have. The one I'm showing you on the right, we'll start off with a positive correlation. A positive correlation means that two things are related in a positive manner, which means they are behaving the same way. The example I give you here, pairs of shoes. The more pairs of shoes you buy, the more money you're going to spend. So as the number of pairs of shoes increases, the amount of money spent increases as well. By the same token, if the number of pairs of shoes you get decreases, you buy fewer pairs of shoes, you're going to spend less money. That is a positive correlation. That means those two are related in a positive manner, meaning as one increases, the other increases, or as one decreases, the other decreases. You also have a negative correlation, and a negative correlation would be something where the two variables that you're looking at behave in opposite manners. So for example, absences and grades, theoretically. As the number of absences you have drops, the fewer absences you have, the higher your grades go. That is a negative correlation. As absences drop, grades increase. By the same token, if your absences increase, your grades are probably going to go down. That is a negative correlation. There are things that are not correlated at all. There are things that have nothing to do with each other. And an example of that would be the weather and what color your car is. The color of your car has nothing to do with the weather. If it's cold outside, that has nothing to do with what color your car is, or what color anybody's car is. Those two things are completely unrelated. So those would have no correlation whatsoever. So for negative and positive correlation to be present, there has to be some kind of relationship between the two variables and factors that you're looking at. So let's look at, first of all, how to find the correlation coefficient, and then how we can assess it, how we can evaluate it and understand its meaning. So what you're going to do is, you've already got your data set, right? We're going to go to the home screen, and we are going to go here. This is the calculator adder. That didn't sound very good. So we're going to add a calculator. Once we add the calculator, we're going to go to the menu. We're going to go to Statistics, Stats Calculations, and then we're going to go to Linear Regression. We're going to click on Linear Regression, and once you click on Linear Regression, you're going to tell the calculator where your X values are stored and where your Y values are stored. Well, what was our X list? It was X. So I'm going to choose X was my X list. Y is my Y list. Now, if you hit this arrow to the side here, it brings up all of the lists that you've used already. So we used X already, it's already in the system, and we used Y already, so you could do it that way. We're going to keep everything else the same, and it's going to run your regression. So what it did here is, there's your MX plus B. There's M, there's B. You have R down here. This is your correlation coefficient right here, R. Now, with R, what you can see with R is that R right here, that coefficient right there is 0.999874. It is a positive correlation at 0.999874. A perfect correlation, meaning two things are perfectly related, is a 1. Think of it as a 100%. So let's look at something that has a negative correlation. I'm going to go to Menu, and I'm going to enter a new grid. Let's look at what we were talking about here. Let's talk about grades and absences. So I'm going to make this, I'm going to call this absences. I can name it whatever I want. And I'm going to call this grades. So let's say, or we'll just call this grade, the actual grade you got in your class. Let's say if you have one absence, your grade is a 98. If you have two absences, your grade is a 95. If you have 3 absences, your grade is a 93. If you have 4 absences, your grade is a 90. If you have 5 absences, your grade's an 88. If you have 6 absences, your grade is an 81. If you have 7 absences, your grade is a 75. So we've just made an absences versus grades table. This is going to be something that's going to have a negative correlation, because you can see as my absences increase, my grades decrease. So you're going to go to the main menu. You're going to go to your home screen. You're going to hit Calculator. We're going to go to the menu. We're going to do Statistics, Calculations, Linear Regression. I'm going to hit this little arrow, and I want absences to be my X coordinate and my grade to be my Y coordinate, and I'm going to click OK. Now, if you notice, right here, my correlation is now a negative 0.971473. It's high, it's close to -1, which means it's a very high correlation on the negative end, just like it was on the positive side for the other one. And the reason it's a high negative correlation is because as your absences increase, the grades decrease. A good way to tell on your correlations over here, -1 is a good negative, that's a perfect negative correlation. That's where one's going up, one's coming down. +1 is a perfect positive correlation. If one is going up, the other is going up. Or if one is going down, the other is going down. The further you get from either of these, as you approach 0 from either side, your correlation is going to get weaker and weaker. 0.9 and -0.9 are high correlations. They're strong. Just to kind of review you, we had our first table here. This is a positive regression, right? A positive correlation. And this one came out to almost be 1.0. It's like 0.99. This is almost perfect. And then we had this data here, which gave us the negative. So let's graph this data here. I'm going to hit Control, Document to add a document. I'm going to add statistics. Again, tell it here, I want this to be absences. I want this to be a grade. That is a negative correlation. You can see as the absences increase, the grades decrease. So that's basically what your R coefficient means. It actually tells you how well related the two values are and how they're related. Are they related positively, meaning they both behave the same way as one increases, the other does? Or are they related negatively, as one increases, one decreases? And how strongly are they related? Anything 0.6 and above, close to 1, and anything -0.6 and below, approaching -1, are considered strong correlations.